Good day, everyone. My name is Nyrika, and I would like to welcome you all for our first ever MKI panel discussion. The topic for this event is AI for smarter energy management. So we'll have a panel discussion with 5 of our members. The first person I'd like to introduce is Sergio Zambrano Perilla. He is a PhD researcher in artificial intelligence applied to smart grids. He also has an experience in electrical power systems, sustainability, and reinforcement learning. He's interested in projects related to smart grids, machine learning, energy efficiency, electrical vehicles, and renewable energy technologies. Our second speaker is Gargya Gokhale. He is a PhD student at IDLab, UGent, IMEC, and a part of AI for Smart Grids research group. His research work is focused on the application of reinforcement learning for the demand response in smart grids. Our third panelist member is Giancarlo Marzano. He is an ambitious electrical engineer with the focus on signal processing and energy management. He's always curious and open to new challenges. He also wants to contribute to the big transition that Europe is facing towards a smarter, digital, and more sustainable society. He also envisions a more dynamic electricity market where end consumers play a key role via enabling services such as demand-side management and decentralized production. Our fourth panel member is Rosanna De Gomez. Has a PhD in astrophysics and is currently dedicating her career to technology for social impact. She is passionate about working in AI applied to social impact, having experience with the work at startup NGOs. And then finally, I would also like to welcome Dr. Ritula to join in with our discussion. And I'd like to hand over to our speakers.
Great, thanks a lot. I guess I'm Giancarlo.
Thank you so
here.
much.
Oh, yeah, go for it, Sergio.
Thank you so much, Nyrika, for your introduction. I would like to express how happy I am to be part of this event, part of this panel, and yeah, also would like to give the word to Giancarlo.
Thank you, everyone.
Thanks. Great, indeed. Super nice to be here, and thanks a lot for the great introduction, and also thanks to Ritula for the great bridge and the keynote which she creates. We would like indeed to take some points which she has been mentioning in her presentation and set up a bit the scene in order to introduce our first panel discussion. In here, we would like to tackle the topic of different applications of artificial intelligence across various segments of the energy markets, and considering different assets which are appearing within these systems. As Dr. Ritula already mentioned, we are going through an enormous transformation through the energy system. And we can see that on both ends, both on the production side, by seeing a new type of renewable energy sources being introduced, wind and solar, for instance, but also on the consumption end, where different consumers are becoming more and more interested about their energy usage. I think that the example of PG&E was a very good example of this, where actually you can consider yourself as part of a neighborhood and see how are you playing and how are you doing with your energy consumption and your basically sustainability perspective, also compared to other similars. Within the distribution network, so at the lower end of this power grid, we're seeing a lot of new assets being introduced, such as electric vehicles, battery systems, and this really creates a very big challenge in order to ensure to maintain a reliable and efficient distribution of the energy, and maintain the situation in which we don't occur cases as the blackouts, which as she was mentioning before, happened last month in Texas, but also in the past all around the world. AI is one of the key enablers, most likely, which will support us in order to obtain this type of solutions. And we could start here and just list a lot of different applications which will make this real, such as, for example, the better forecasting of production, consumption levels, prices within electricity markets. At the same way, also artificial intelligence can support the operation of these assets, such as electric vehicles and batteries. to actually operate in an efficient way and support the grid, while instead they would create a challenge. So basically, this is a key moment in which we can take this opportunity and actually, instead of making it a risk for a reliable distribution of energy, take it as an opportunity to bring an even better service than it was in the past. So with this, actually, I would like to also consider another aspect, which we can discuss about AI, which is also the possibility of introducing and integrating the human behavior and the human patterns within what is actually being done, usually just from a technical perspective. The power system has been always, as Dr. Ritula mentioned, one directional, going basically from production to consumption. But today, also the end users integrating their patterns, their habits, their necessities, could make it a two bi-directional flow. And indeed, before getting in too many words and just going in listing different applications, I would like to bring up a question also for my other panelists, which is, what do you think and what do you consider the most interesting of the different applications which could appear in the next years thanks to artificial intelligence within our power grid?
Thanks, Giancarlo. Well, I was very interesting in your introduction. I was kind of daydreaming about all the things that could happen, and also to consider some of the points of Dr. Ritula's presentation. One of these aspects that we're seeing, and it's definitely happening right now, it's like, okay, how much are we actually deploying this? Well, it's actually not yet. We are going there. There are many startups. There are also many initiatives between well-established companies that are trying to go there. And what I personally find most attractive, and of course it's like my research topic, is about how can we design some smart controllers? How can we take advantage of all this information, all this data that we have from different sources, from different varieties, and start deploying some new applications? Such as we kind of stop, or let's say we improve all these typical controllers that we have. So we do have, let's say, some knowledge from centuries about how to operate the power systems, but the power systems are changing, and are changing like so fast with so many new assets, so many new elements. So definitely these all methods, these all theories that definitely work and used to be good are not enough. They are not enough as we are getting more renewable energy sources, as we are getting our consumers more involved with their own assets. They have batteries, they have PV, they are definitely going to be part of the new electricity markets, of the new energy sector. And of course, it's the definition of a prosumer, where we don't only have consumers, but we also have producers in downstreams in our electricity grids. So all of this requires a new mindset. We cannot use anymore all the previous theories or the previous methods. And in my particular case, when my research is about multi-agent reinforcement learning. So how do we treat each one of these points in the power system as an agent, and instead of thinking about centralized control, as it is usually in some sort of a SCADA and so on, how do we enable all the information that they have, all the communication that they have between each other, and leverage that into new kind of control, into new ways of taking actions, so as to preserve the quality in our power grid, which is the ultimate goal.
Hey guys, I'm Gargya, and I would just like to add to what Sergio said about the aspects of generating smart controllers, because for me, the biggest takeaway from Dr. Ritula's presentation was that the major difference between our conventional grids and the smart grids has been the introduction of bidirectionality, be it bidirectional energy flows or be it bidirectional communication or control. And so I genuinely believe that with whatever data we are generating, with all these things that we have, would remain untapped resources if we are not able to use them in this evolving nature of our grids, where we must go from our conventional approaches to data-driven control methods, and just not stay focused on using our centuries-old models and the physics of our models to actually govern how we are going to control our assets. And like one of the questions that's there in the chat as well, and about the blackouts and about large-scale batteries and those kind of things, I believe that with these assets that are now coming into picture with more and more EVs as well, I think it's getting more and more important if we can generate controllers that can actually adapt to different situations in different places and can be used by different people in a very hassle-free way, but they still want to get good results. Like in the case study that Dr. Ritula mentioned, that yes, you're using less energy and you can track your energy very easily and you can see those graphs. But what people also want is something which is just very easy to happen, something that's just happening at some backend, and they just want to get the benefits out of it. That okay, I'm just saving a lot on my energy, or I'm just say using all the locally generated PV that's possible. And so the biggest uh, contribution of AI here could be to actually get to that place by generating some nice controllers that can keep on adapting, keep on learning, and give us good results.
So I guess I'll just jump in. Can you guys hear me well?
Yeah.
Cool. So hi everybody, and yeah, I'll just quickly thank again for this amazing presentation, also to Richard and Nyrika for the invite and all the support for preparing for this event. I think that the question is quite interesting, and you can see it like the advances of AI, or what AI can do for electricity, can be seen from two perspectives. Maybe, for example, from the developed countries, we can finally come to this point where we were all like dreaming of the 21st century as something very futuristic and so on. And we can finally have this integration of like what we call of smart in electricity grid into our own homes. For example, you can come home and you can understand how your own grid works and how you can, for example, consume less energy and like save money and so on. But from the developing country perspective, that in some cases, for example, if you think about the African countries, that people don't really have simply access to electricity, and then you can start to have like a smart grids with AI that can make the entire system more efficient and decentralized. And you can start have, as I think Sergio mentioned before, that the consumers become the producers, and this makes a huge impact in the lives of some people, especially, for example, in rural areas and so on, where sometimes they don't even have electricity at night to work, like we still have in the world. In case some of like our audience doesn't know, like we still have regions in the world where people don't have electricity, like and we have kids studying and so on. And then if you can just give this power to people, like literally like the power of producing their own electricity. So this is something that is really inspiring, actually, to kind of pursue this goal of having integrated electricity systems for the world.
Great, thanks a lot to all of you. And I don't know if maybe Ritula also wants to add something on this, like maybe her opinion, her take.
Yeah, as very rightly said, when you talk about the demand side management, as one of the panelists also mentioned about it, that it's not only about saving the money, but of course, like disaster management. I think somebody mentioned about the disaster management, how the this data analytics it could be used. Then that we all know about that hurricane. Sally, I think it happened in the year 2013. In that case, thanks to this data management, we were able to restore the whole system in just 2 days, which would have otherwise taken months and months to happen. And that is one of the aspect of one of the application of big data analytics in smart grid. In disaster management, I think one of the panelists mentioned that.
Nyrika, I'm wondering if you want to just pull out some of the messages that are coming through on the chat as you moderate this conversation.
Yes, definitely. So we have a question from Richard. He says that he would be interested in the panel's view of the ultimate delivery of many of the benefits of smart grids through changing behavior of consumers. To what extent is the AI ML work being linked to social studies, human behavior studies to develop a more holistic implementation plan?
Okay, that's a great question. I have a bit of experience in working for a startup that is actually trying to, let's say, compensate or not compensate, to compile a whole bunch of residential units, and that they all have their own PV and their own batteries, but essentially they are residential units. So we are moving towards, let's say, a world where people that are participating in ancillary services, like in the electricity system, are not only like big utilities, are not only like the classic generators, but are basically human beings, let's say, like living, like using their electrical appliances. They charge their vehicles. They use the washing machine, the drying machine, and it's impossible to think about implementations of these new technologies without considering how is the human behavior, how are the human patterns of use of this equipment, that at the end we are definitely using them so as in demand response schemes and as part of our artificial intelligence and machine learning stuff. But of course, I want to be able to use my washing machine whenever I want to use it, or my electric vehicle, I want it to be charged when I want to use it. So definitely, where we really need to take into consideration all of the usage and the pattern behaviors of people, and that becomes one of the inputs, that becomes one of the sources that maybe we can even use some ML techniques to try to predict, or to try to make a forecast of how is going to be the usage of the systems. Or we can also collect from a bunch of data that we already have, and part of this big data conversation that we're having, and try to use that to actually be able to design controllers that work well both for the users and to the demand response schemes.
Hey, and one more thing just to quickly add, the PhD project that I'm working on right now is also similar to what you just mentioned, where we actually have a component of work that looks at the behaviors and the, say, mindsets of people involved in different pilot projects, to actually consider that as an input for developing these controllers or these smart energy management systems. And so the idea here won't be actually to influence the consumers in a very direct way, but to actually understand or learn their behaviors, and then try to create some form of wiggle room where we can actually optimize for different aspects. So that is, there are a couple of projects that are going on under the Horizon 2020 European Union, the research program. So that's but still these are under research work instead of actual implementations.
Thank you for that. We have a few opinions and questions from Alexandra and Swan as well. So the question, I'll just go to the question bit where Swan asks, will it be yet again a paradigm change with smart cities where society and behavior will be ultimately connected with AI? And the next question follow up for that is, how do you make sure that the big data you are collecting is good data? Do you use supervised methods for your models?
That's
Can I
definitely one
take
for
this one?
Rosanna, isn't it? To start
Yeah, I
us
was
off
kind
with.
of.
I saw you
Yeah,
nodding like this.
Yeah, I'll just jump in then. Yeah, thank you so much for this question. I think that in a way we can already think that we are already connected to AI, like in our behaviors, because if you think, like, I mean, maybe not in the sense of smart cities, but like all the AI that we consume every day, for example, with, I don't know, if you listen to music using some platforms such as Spotify, or if you like, we have a lot of this AI conjunction with humans, so to say, like in the entertainment these days, and of course like shopping and so on. So it's a byproduct of digitalization, basically. So in a sense, like we are already getting to this point. And this is actually something that I was planning to talk later on, but like this is exactly like in a way, there is no way around us going to this direction of digitalization. So of course, like, I mean, that doesn't mean that it's just like, we just throw ourselves into AI and so on. Like we have to have some sort of system to still have some transparency, and so we can still know what is going on. But this is something that is already happening. Let me just check what was the second
Do you want to
question?
mention Omdena as well, in terms of, since AI for Goods come up?
Sure. Yeah, so like, I think in the sense, like we were also discussing, for example, before about like this notions of how AI is using and is being used, sorry, and used to understand the behavior of consumers, but AI can also be used in the sense of understanding the mindset of, or the sentiment of what people are having in, for example, in the energy transition. And this is actually a project that happened at Omdena. So for those who don't know, Omdena is a platform for like that puts together data scientists and experts in projects related to social impact. And this is where I've been dedicating my work for quite some time now. And in one of those projects, there was exactly, this was if the, I think the World Energy Council was to understand how people perceive the energy transition. So we used techniques, I'll talk a little bit more about it later, but like techniques such as NLP to just see what people are saying about the energy transition in social media and so on. So this is a way to, for example, try to connect AI with the mindsets and how people perceive things, specifically in this topic of energy transition. So quite interesting. I'll talk about it later, so like spoiler.
Yeah. I would also like to answer one of the question of one of the participants. They're asking that instead of just suggesting the customers, is there any way that the devices will be proactively doing it? Yes, definitely, because that is the work of the artificial intelligence. No? When you train the system, when you train it, that okay, during this time, peak time, the your tariff will be high, so you automatically shut down your washing machine. So the customer doesn't have to do that. He's sitting in his office, he's working, and the AI is helping his smart machine to know that, okay, at this particular hour, it's a peak time, it's a peak tariff time, so I don't have to operate it. At this time, the tariff is the lowest, so the machine has to operate. Definitely, that is also going to be a part of smart grid. So I think that's one of the answer to one of the questions participant was asking.
Thank you, Ritula. So I would like to go back to one of our questions by Richard, because Sergio would like to address it in a little more detail. So it says,
say smart Richard, not dumb Richard, just to be clear there.
Yes, yes. So he says, I would be interested in your thoughts on grid-scale energy storage required to cope with intermittent renewables. Also, how to improve stability and black start with the reduction of physical inertia within grids.
Oh, actually, I'm pretty sure that Giancarlo has something to say here.
Thanks, Sergio. Yes, indeed. Like, I would love actually to take on this one. As you can see, I don't know if you can actually see my screen back here. This is actually a storage system which was coupled with a large PV plant on an island. This is actually a very common business case in many situations in which you get to connect and you get to basically like supply most of your electricity from an intermittent load. And as we all know, like there is not only the long-term forecasting problem, like trying to predict the weather, trying to predict how it is going to affect the production from my intermittent source. But it's also like some very short-term intervals in which you have like very severe changes of production. This could come, for example, from just passing by of a cloud, some type of shades, or like even like some dirt and dust on your panels, or some of these type of problems which might indeed affect your production from renewables. And large-scale storage is definitely something which can support on this and can definitely help stabilizing the output of the system, basically by trying to do something which is called capacity firming. So trying to balance what can be like the like trying to up or down regulate in order to maintain the same level as forecasted for the energy production. And this obviously like creates several advantages for both for the plant owner, because this way you can have like better forecasting and like way more reliable operation, but also for the system operator and the market operators, because this can also support in order to actually have a better prediction, like have more stable supply of the electricity, which as we were mentioning before, it's definitely one of the ultimate goals.
So to add on to that, Dean has asked, how do you solve storage issues?
Storage issues, what are exactly intended for those? Like maybe can elaborate a bit more on that. I also see that actually like I didn't answer the second part regarding black start. So while Dean maybe adds some like elaborates a bit more, I can also comment on the black start. That's indeed like a very important feature, and like that's a very important capability which is often required. I can think of systems where, for example, like we are connected to some very important loads, which can be, for example, an hospital, or example, the cases in which you want to actually supply most of a load from a city or from like a residential aggregation with intermittent sources. Black starting and ramp rate control is definitely like some of the other features which are really important to take into account and to manage in an appropriate way in order to not create and not to inject these disturbances inside of the main power grid and power system. One way, obviously, to solve that, like what I would say that I'm also a bit by part, it's the imply of the battery and battery storage systems, but that's definitely like not limiting to that, and that's not the only solution for it. We also have like other technologies which are able to react and to cope basically with these variations. Obviously, what is very important to consider is the different requirements on a grid level. What is the required time for reacting, and that's a key element in order to choose the appropriate technologies for managing this ramping and managing these basically these stability and black start requirements. And,
thank you for answering. So the next question I'll move on to is against Dean, but he says that AMS and Microsoft are offering different kind of smart grid solution, IoT solutions, and they promise security for data collection that we don't understand. So I think he's asking a question like, when the data are collected, how do they understand whether the data is safe or not from these companies or organizations?
well, I don't know if maybe someone else want to have a take on this. Most likely, oh yeah, is that possible to speak?
Sure,
maybe,
yeah, Dean, go ahead. Yeah.
Yes,
go for
please.
It. Go for it.
Yes, please.
Was that a teaser, Dean? Or did you mean it's possible to speak about that rather than were you asking if you could speak? Okay, not a problem. Giancarlo, pick it up or throw the baton, so to speak, to somebody else. Oh, we can't hear you. No, Dean.
No, we can't.
Sounds like some mic trouble, Dean, if you're not muted, that is, of course. He'll be back. Not a problem at all. That's how these things go.
The beauty of this digital. Yes, exactly. I wanted to pass it by to Sergio, exactly.
In the meantime, I saw a question regarding how do you make sure that the big data you're collecting is good data? Do you use supervised methods to your models? This is a really good question, and it's actually related to a topic that a colleague of mine is working on, and I really like it actually. So you do know about all these generative adversarial networks that are kind of booming the internet lately, where people are making deep fakes, where they are actually able to create videos or images of let's say famous people, like the Queen of England, for instance, like saying things that they're actually not saying because it's actually not them. So what they're doing is that they're using some neural network architectures to, let's say, to deceive a learner and to create fake images that really look like they're real. And if we take that into consideration, but if we go back to the energy storage world, this is also another way of let's say, creating synthetic data, and also to take existing data that we don't know if it's good enough or not, and kind of try to test it. And this is, yeah, definitely some kind of a supervised methods that we're using. So in that regard, we also are able to, at some extent, evaluate the quality of the data that we have, and if we don't have data, actually to be able to generate synthetic data. And this is something that is that has a lot of value, because let's say for us in the research world, sometimes we do have data, but we don't have a lot of it. And many of these methods for training and for our algorithms will require a bunch of it, like many information that maybe we don't have because it doesn't exist yet. So by trying this generation and these synthetic data methods, we're actually able to, let's say, supply ourselves with good quality information that is also able to enhance our learning methods.
Thank you. So our next question is from Amandeep. He says, for smart grid, should we move towards DC transmission as compared to AC transmission? As most devices like electric cars, fuel cells, and solar power is all DC.
Yes, Mr. Amandeep, of course, the concept of DC homes, it is, although coming to picture, but you see, all the devices which we have, the domestic devices especially, which we have at our homes, they are mainly based on AC. And it's not possible to completely, remake on DC or something. So I think what you want to say is that because all our these renewable energy sources, since they're generating DC, so that's why you want to go towards DC appliances. I think that's what your question is about. So yes, DC home is one of the concept which is there, but you know, DC again, it has got its own disadvantages, like it's not that safe as compared to AC. I think the others, they can pitch in about it. About the there are safety issues also.
Yeah, like I actually wanted to ask you about this, that when we consider DC systems or distribution systems in a meshed kind of an approach, do we have good or reliable protection circuits like circuit breakers or something? Because I believe in our AC systems, one of the biggest advantages was that there is a natural 0 point where we can actually break our circuit, and the DC systems lack that natural point. So is it still, like, has it been done, or is it still being researched upon?
It is being researched upon. I think the safety is one of the main issues in case of DC, which is the kind of hindrance as compared to AC.
So the follow-up question for that is, can we go for dual transmission?
Can you please elaborate what is dual transmission you want to say?
Amandeep,
like HVDC?
Amandeep, if you could provide us more information about it, it would be great. You can unmute and talk. AC and DC is what he says.
That I'm understanding, but how do you think, like for the transmission, you want to go towards AC, and at the receiving side, you want how do you want to have that hybrid? That's what I want to ask from you.
As the efficiency of devices is increasing, so the power consumption is also decreasing. So therefore, we can go for AC or DC.
So you want to say that for the transmission side, we can go for AC because of the losses, concern of the losses in case of DC. And when at the consumer side, we can go for DC.
Yes, ma'am. Because the bulky devices are there, like chargers, mobile chargers, laptop chargers, all these are
Yeah, that's what I said.
requiring that.
Yes, that's why I said the concept of DC home works on that only. But then again, you have to come up with appliances which are mainly based on DC. Again, that will be, the shift from AC to DC. It will take some time. Of course, in some European countries, this concept is coming up, but it will take some time.
Now, inverter technology is there. Now, like AC is now working on inverter, fridge also on inverter. So they are converting AC into DC, and then they are again converting it into AC.
I understand. That's what you're trying to say, that so we can eliminate that thing. But as I said that, one thing is that you make your home as the DC home. That's a separate thing. But since all the appliances which are made which are available in the market, especially the home appliances, they are based on AC. So for that, you have to make a complete transformation of all those devices.
Okay, thank you.
Thank you. And I think Dean is back. So would you like to ask your question?
Yeah, please. Thank you. I'm sorry. Can you guys hear me now?
Yeah,
We appreciate hearing you, Dean. It's great.
Awesome. Perfect. Thank you. Thank you very much, guys. So I can present myself. I'm sorry, my camera is off because due to our operation. My name is Dean, and I'm a student of Hyper Island. So what I'm studying is AI business consultants. So one of we get a lot of client projects. So one of our clients is building solar parks, and there is about the smart grids and all those solutions that we have presented to our clients, and we had a really big issue with the storage issue. Like, how can we, as you've seen, our population is growing really fast, and it's not enough energy we have. It's not enough solution we have, and all the new energy, renewable, sustainable energy that we have is not enough, and it's not going to be enough because we don't have any storage system. We don't have any good storage system anyhow. It hasn't developed yet, or I didn't find it, maybe. But I think so it hasn't developed yet, because if you check it out, the lithium ion batteries, they're very explosive, and it costs a lot. So there are new startups has come up with the sodium ion solutions, or the liquid battery solutions. But do you guys have, which kind of solution you guys having, and how do you solve that problem with the storage here?
Well, maybe personally on my side, actually, thanks a lot for the question, Dean. I personally do not actually have an answer to that. Like, thanks a lot for the point you bring up on there. Maybe some of the other panelists as an opinion and would like to comment on it.
Yeah, one opinion I had about what you talked on renewable energy being there but intermittently, and that's the need for storage. I would also like to argue that maybe that's where we are actually focusing on when it comes to demand side management, where instead of keeping this in mind that, okay, whatever excess energy we are producing should just be stored somewhere by some magical device, we would try to try to make our consumptions flexible in a way that we are consuming the most when this sort of energy is available. So if you are in a place like India, we would try to shift our loads during the daytime where we have a lot of solar energy, or if you're here in Europe where there's a lot of wind available during evenings, nights, or some of those time spans, we would try to shift our loads there, and then we would just have a smaller surplus which can then be, say, stored into the conventional ones, or into the ones that are there, say, in local homes, or in terms of EVs as a distributed energy storage network, or things like that. So that's my opinion on the storage battle per se.
All right, thank you. But it's still like it's not enough. It's very little, we are building smart grids, or we started building a smart grid. We started building like the really big solar panel parks and other sustainable energy resources, but we still haven't found where we can keep that energy, how we can keep it safe, and when we really need it, when there is blackouts, and then exactly then we need that kind of energy, and we haven't solved that the big issue. You understanding what I'm doing? We're a little bit backwards kind of thing. Like.
Yeah. As far as storage is concerned, we do have grid storage batteries, and apart from that, there's a concept of these pumped hydro also, wherein they are not only used for the storing the excess energy, but also because, as I said in my talk, one of the problem with renewable energy sources is the inertia, the low inertia. So they can contribute towards that also.
All right, thanks. So which kind are you using, like a kind of lithium ion, or which kind of battery storage are you using?
Ritula, do you want to go for that, or like maybe I can also
yeah, you can answer that. You can answer.
Sure. Indeed, like, so there are actually like for grid scale storage, there are actually like I can speak like regarding the lithium ion technologies, which you can see like in different continents operating like at very large utility scales. There are examples in Australia, for example, the Hornsdale battery site from Tesla, but also like in Europe, we can see them in Belgium, like also in different installations which we have in the UK, and so lithium ion like has been proven to be efficient for this type of operations and this type of applications. Nonetheless, indeed, as Dr. Ritula mentions, like also pumped hydro has similar potentials, like and similar support. I would say that like two main, as I was mentioning before, every different use case has its different suitable technology to be applied. And for example, like one main difference which I would start from between these two, pumped hydro is well known to be way slower to react compared to battery system technologies. So for example, in case I would like to consider something as a frequency regulation or like some very fast type of response, then like we should for sure try to opt for a technology like batteries compared to pumped hydro. While for instead like applications which are slower reserves, then like you would consider indeed like some type of applications, such for example the pumped hydro. So I kind of say that indeed like there is no unique tool for fixing it, but indeed like we need to actually take all these different technologies, all these different developments, trying to integrate them in the proper way, and I think that's actually the only recipe in order to get these future smart grids, integrating all of this. And just to complete, maybe like to go back a bit to the flavor also of artificial intelligence, what better than an artificial intelligence controller can actually decide how to dispatch these different technologies, how to operate the investments in the different technologies, because indeed all of them have different time span, different duration, and different capex and opex, so like different ways to actually model their economics. So by considering all of that, we can also like use artificial intelligence in order to develop the best portfolio of technologies to be installed in order to cope with these increasing complexities which we are seeing and we are facing on the power grid level. So I hope that actually answered that.
Yes, yes. Thank you very much. Thank you for the answer.
No worries, my pleasure.
Thank you so much, Dean, for coming up and asking your questions. It was really an enjoyable talk. So the next question I have is from Callum. He says, do any of the panel members have experience in applying the principles of graph theory to model power networks? It's taking off in the water utility sector to map out events occurring in the water network, and it might be a brilliant theoretical tool for power systems as well. So he'd like to know your opinion regarding that.
Yes, absolutely. It has been used in classic problems in the power systems, such as fault locations, because of course we have the power grid, and the power grid is basically composed with a certain number of nodes and lines. So this can be easily modeled as a graph with nodes and axes. And but by using these classic methods such as the short distance and the shortest path algorithm, we're able to solve problems that are present in the power systems. And right now, it is also possible to think about how do we use all the information that we have in the way of a graph, where we have structured data. We know that there are some nodes that are connected between each other, so they are most likely to affect one to the other when there are disturbances or when there is a high load, low load, high generation, and so on. So based on the information of the graph, well, we have some implicit information about the structure of the power grid. We're able to get, like, let's say, one more layer of information that is let's say, perpendicular to what we have regarding the voltage and currents and angles and so on, all the classic information that we have from PMUs and the metering devices in the grid. So when we add all of these, we are able to actually try to implement very smart things, such as in the case of multi-agent systems, where we have different points in our power grid, and they all can communicate between each other. And how do we implement smart controllers based on the relationship that they have between each other, how close they are, who are neighbors, who is going to affect me, who am I going to affect with my decision making. And all of this is with this mindset of maybe stop thinking about the centralized control, where we have like this huge SCADA at the beginning of my power system, and we go to some kind of democratization where every one of the agents or every one of these prosumers of nodes in the system is actually able to learn about their neighbors, about themselves, and take some actions without having to ask someone else. So that's some applications that we'll definitely see regarding graph theory.
If I may add to what Sergio was saying, like exactly using the same system, like as a graph or like with nodes and the transmission lines and so on. This is pretty much, for example, what we do, at least like what I did like in my first work with research in this field, like in the Frankfurt Institute for Advanced Studies, is exactly creating this network and using, for example, for estimating the cost of energy and how you minimize the cost of energy and how you minimize the production of, for example, CO2. So like you have all this fossil fuel energy sources, and then you have like all the combination of all the other sources and how you can take this complex system. For example, each node is a country. For example, in the EU, we have quite well known knowledge of how the grid works. And we can try to see if this and these countries collaborate together, how we can minimize the cost of energy and at the same time also the production of CO2, for example.
Amazing, thank you guys.
Thank you so much for your question. And the next question which we'll move on is, where is the optimum location for energy storage? Ground, roofs, below ground, or does it not matter? This is a question from Alexandra. So would any one of the panelists like to answer?
Well, yeah, I can give a first take on that, and then let's see if anyone wants to follow on it. I would say that actually, like energy storage, the first question we would have to relate to that is like, what size are we dealing with? What size are we talking about? There are like storage solutions which can go like to very small, like just a bunch of kilowatts, going up to megawatt size, and that definitely occupies different sizes. Then secondly, we can also consider that the same type of technology can be covered by different type of chemistries. This affects both their operation and also their sensitivity, let's say, to external factors. So there are some type of storage systems and storage technology which are actually containerized, so which can look like something like here. So there are like large containers, like very big stuff, and these ones basically like are made in such a way that they should be able to actually withstand different environmental conditions. However, like there are other solutions which instead are en plein air. They are like in the open basically, and they can be like like they actually need to be covered by some other means, like they need to actually be in some very covered positions in order to actually not have like any effect from the external rain, dust, or just the temperature itself, which can affect their operation. Underground, I actually like never had the experience of seeing those, but I actually don't doubt that they could exist. Just that I didn't see them yet. But I think that indeed, like it's a bit depending on the project, depending on the technology which is implied, and depending on the type of size of the system. That situation could change also the location where they are installed.
Thank you. So the next question is from Amar. He says, is there any commercial viable vehicle to grid or vehicle to home solutions? So his question mainly says, can we actually use these electrical, grid vehicles to our homes? Is it feasible, or how long will it take to see this application in future?
I think his question has already been answered in the chat box itself. He's writing that yes, there are few V2G trials in the UK. OVO Energy Company did one too. You can see that. Somebody has already answered that.
Thank you. Thank you for pointing that out. So our next question is, yes, our next question is to Dr. Gomes. Where do you think adoption of AI-based solution is more viable, on the customer front end or at power production facilities?
So I'm not sure if I understand the question, but like, if we see it from the perspective of a customer, in the sense of like producing services that the consumers can use and so on, we have to think that this is all connected. So to be able to actually come to the user and say, here is how you can, I don't know, manage your energy at home and so on, it's really intrinsically related to how you, for example, use AI for forecasting the energy, either demand or supply. So this is all connected in a sense. So like the techniques, of course, that are used are different. So for example, for supply or demand, we basically have to use time series on maybe other techniques as well. And for example, anomaly detection and all these things. But like for coming from that to actually giving this information to the consumer is basically taking this data that you're using and analyzing it, and then you just transform this into information to the user, so to say. And the information, like applications of AI for the users, can be, for example, recommender systems and maybe classification of, for example, of what kind of application that you have appliance that you have at home is producing more or less energy. So it's I would say this kind of like all connected, but I don't know in terms of being viable, but the most important for sure is actually focusing on understanding the grid itself. So I hope it just answers the question. I don't know if anyone else wants to add to that.
Well, yeah, I actually think that like it answered it well. Like I think that, however, like we'll see if what they think on the audience. But I completely agree on your view, and maybe I would just like to add a small part regarding actually that we have something in between the consumption and the production, which is also the operation, the grid management, the grid operators. And on that side, at least to the extent of my knowledge, in Europe, there are several applications of AI which is being carried on in order to actually manage the grid and also procure the different services which are supported for the grid. So indeed, like frequency and voltage balancing, capacity markets, many of these different applications are actually from different TSOs and DSOs, like for example, indeed also flexibility market trials are being studied with implementations of AI and machine learning solutions. So indeed, like that's there is indeed like the need on both sides, but also this part in between, which is managing and a bit overlooking of what is going on. It's also adapting quickly to these new technological and software developments.
Thank you for that. And the last question for today's panel discussion would be from Likta. She says, is it feasible to implement smart grid solutions on a subset of systems, or is it a collective effort where energy system involves should adopt to this change? Every system involved should adopt to this change.
Can you please repeat the question?
Definitely. Is it feasible to implement smart grid solutions on a subset of systems, or is it a collective effort where every system involved should adopt to this change?
You see, as I also already said in my talk also, that smart grid is a concept which is being implemented in stages. Like right now, we are implementing AMIs, as I said, advanced metering infrastructures, and these PMUs, the synchrophasers, they are being implemented. But yes, I mean, it has to be a collective effort in the sense that it needs the involvement of electrical engineers in case you want to say, and like computer science engineers and all, in case you're trying to talk about that. Can you please elaborate what you want to say when you're saying collective efforts? I didn't get the question properly. But as far as implementation is concerned, it is being done in stages. It's still in its infancy stage only. So can you please elaborate what you want to say when you're saying collective effort?
Thank you, Ritula. Yes, please go ahead and ask your question.
In the sense, yeah, collective effort in the sense, what I mean is like every system which involves from like the energy generation to distribution to the end consumer.
Of course, of course. Smart grid, as I said, that in the infrastructure also, if you remember my presentation, it was generation, transmission, distribution. So our conventional electrical grid is there, but of course, integrated with that, there is an integration of the information technology. So all of them have to be involved. They can't work in isolation. If that answers your question, does that answer your question?
Yeah.
Thank you so much. And here comes to an end of our panel discussion.